Hi guys. So we have this question under momentum and collision. Let's see how we can break it down. So the question reads, a hockey puck traveling at 30 meters per second on a smooth ice surface is deflected by an angle of 30 degrees from its original direction. So this happens when it collides with this other object, which was at rest. Then the second puck is pushed downwards with a velocity of v2 prime that we'll need to calculate. So the angle for the second pack is 60. The angle for the first one is 30. So let's just draw it here so that you understand what is actually going on. So basically this is what we have. We have the first object, which was moving at 30 meters per second. So it hit this other object, which was at rest. Then after collision, this object that you see here went in a direction of 30 degrees above the positive x-axis. So this one went in this direction, which is 30 degrees with respect to the positive x-axis, while the other one went in this direction, which is 60 degrees with respect to the positive x-axis. So now the idea here is we need to find the components of these two. Remember, this is velocity 1, the initial velocity. It was moving with an initial velocity of 30, so let's just put it here. This one was at rest, so this one, the velocity 2 was 0. But for this one, we have v1 prime. The prime is just representing the final velocity. This other one here, this is v2 prime, like that. So v1 initial, v1 prime final. So since we're breaking them into components, we're going to have a component here, like this, and another component here, so that we form a right angle triangle. Hence, this component here, this will be v1 prime in the y direction. So since it's the opposite, then we're using v1 prime sine 30, like that. This one here, this is v1 prime in the x direction. And since it's the adjacent, then we're using v1 prime cos 30, like that. If we come here, it's the same thing. We'll create a component in this direction and to create a component in this direction, like this, so that this component here will be v2 prime in the x, which will be given by v2 prime cos. The angle this time around is 60. This one here will be v2 in the y, it's a prime, which is equals to v2 prime sine 60. Okay. So now that we have broken it down into these components, let's break down what the question is saying. So it's important to note that from this statement here, which says the second pack requires a velocity at this degree, then we're assuming that the mass is the same because it's a stationary identical pack, meaning that they have the same mass. So since they have the same mass, what we're going to put as the value of mass is just m. So this has a mass m, this one also has a mass m, because this mass is identical. So now the next thing we're going to do is we're going to say, since momentum is conserved in all collisions, so we're going to say the initial momentum is equals to the final momentum. And of course, this is the summation of all momentums on the before collision and after collision. So let's start with the x-axis. So x-axis. So in the x-axis, we can say the summation of the initial momentum is equals to the summation of final momentum, because momentum is conserved. Then since there are two objects that are involved, we can say momentum for object 1 plus momentum for object 2 is equals to momentum for object 1 prime plus momentum for object 2 prime, like that. Now we know that momentum is a mass in motion, meaning that here where there's momentum 1, we'll say mass 1 v1 plus momentum here will be mass 2 v2. This is equals to momentum here will be mass 1 v1 prime plus here we have mass 2 v2 prime, like that. Now let's do some substitutions based on the information that we have broken down already. So we know that the mass is the same throughout. So we're going to replace mass 1 and mass 2 with m because the mass is identical. Then on top of that, since we're in the x-axis, let's focus on what we have in the x-axis based on our diagram. So this m here is just m, like that. Velocity 1, remember this object was moving with a speed of 30. But before that, let's just leave it as v1. v2 is 0 because this object was motionless. So this is a 0, is equals to. Now we have mass 1, which is just mass. We have final velocity in the x-axis for object 1. Let's go back to our diagram. Now remember, on our diagram, let me just do this. From this diagram of ours, we're focusing on object 1. In the x direction, we can see that the velocity is v1 prime cos 30. So we'll substitute this with v1 prime cos 30, because remember we're in the x-axis, so we're just getting everything in the x-axis. Plus this m here, m2 is just m. v2 prime. v2 prime in the x-axis is v2 prime cos 60, like that. Okay. Let's simplify this expression. So to do that, we're going to say this part here will just remain with, remember the velocity we've been given for object 1 is 30. So we have 30 m. We still have m, the mass, which is equals to. Then let's factor out the m, since it's common. So we're going to factor out m. So what remains is simply v1 cos 30 plus v2 cos 60. We factor out m, like that. So since we factored out m, the next step can be to divide both sides by m. So if we divide here by m, we divide here by m, we want to get rid of the mass, so the mass can easily cancel out. So what do we remain with if mass cancels out? So if mass has cancelled out, on this side we just have the 30, but let's start with this side. So let's find the value of cos 30. So cos 30 is giving us 0.87. So this is 0.87 v1 prime. Plus, let's find this value as well, cos 60, which is just 0.5 v2 prime. Everything is equals to 30. Let's call this equation 1, just for the sake of reference. So we'll come back to it. Now remember, this was the summation of forces in the x-axis. Let's sum the forces now, not the forces rather, let's sum the quantities that we have in the y-axis. So in the y-axis, we're going to say the initial momentum is equals to the final momentum, because momentum is conserved. So same procedure, we say P1 plus P2 is equals to P1 prime plus P2 prime. Remember, P is just a symbol used for momentum. So for object 1, it will have the momentum mass times velocity plus mass 2 velocity 2 is equals to mass 1 v1 prime plus mass 2 v2 prime, like that. Now, since this object, or rather these two objects, had motion in the x direction initially, remember it was moving 30 in the x direction, meaning that it was not moving in the y direction. So if that's the case, we're looking at the y-axis this time around. So since this object was moving entirely in the x direction, then in the y direction, initial velocity here is just 0. So m times 0 plus m times 0, because the object was moving in the x direction. Now this is equals to, again, mass is common, just like we did on this side. Remember, it's the same, it's an identical mass. Hence, we can factor it out. So if we factor out mass, what we'll have will be v1 prime plus v2 prime. Then we factor out mass like that. Okay, let's pick it up from there. So on this side, we just have a 0. On this side, let's do the substitutions. The initial velocity for 1 in the y direction, so in the y direction is this one that we have here, is v1 prime sine 30. So this is v1 prime, the sine of 30. The other one is this one which is pointing downwards. Now, because of direction, the downward direction to pick up a negative. So since it's pointing downwards, it will have a negative value. So this is this value that we have here, which is v2 prime sine 60. All this is equal to 0. Now, where has this mass gone? Remember, this side we have 0. So if we divide both sides by this mass, we'll say 0 over that mass, then we'll just have 0. So that's how mass disappears. So if this is the case now, we can simply say, let's push this to the other side so that we get v1 prime. Now, sine 30 is just 0.5 is equals to, so this whole expression goes to the other side of the equation. So sine 60 is 0.87 v2 prime. So let's call this equation number 2. So we have equation 1 and equation 2. Let's see how we can solve them simultaneously. To start with, let's pick up equation 1. So let's start with equation 2. So equation 2, let me write it here, is, let me just write down both of them, 0.87 v1 prime plus 0.5 v2 prime is equal to 30. That is equation 1. Equation 2 is 0.5 v1 prime is equals to 0.87 v2 prime. Okay, so these are the two equations. So now with these two equations, let's solve them simultaneously such that we find the value of v1 prime and v2 prime. From this equation, from the second equation, we can make one variable the subject of the formula. So let's make a v1 prime. So if we divide both sides by 0.5, we'll have v1 prime is equals to 0.87 v2 prime divided by 0.5. So v1 prime is equals to, so if we do the division there, divided by half, we're getting 1.74 v2 prime. Now, this is just a subject of the formula that has come from equation 2. So this subject that we have, we're going to replace it in equation 1. So this is what we're going to get. Here where there's v1 prime, we'll put 0.87. Where there's v1 prime, we're going to put 1.74, the subject, v2 prime, plus 0.5 v2 prime, which is that expression. Everything is equals to 30. If we multiply these two values here, let's see what we get. I'm getting 1.514 v2 prime plus 0.5 v2 prime. So everything is equal to 30. So if I add these two, because they're like terms now, so if I add the two, I'm getting, let's just say 2. So we have 2 v2 prime is equals to 30. If I divide both sides by 2, v2 prime will be equals to 15 meters per second. So now that I have v2 prime, I can easily find v1 prime using the subject of the formula. So I'm going to say v1 prime is equals to 1.74. Here where there's v2 prime, I'm going to put the value 15, because I'm just using this value that I've gotten here. So v1 prime will be equals to, so 1.74 multiplied by 15. So the velocity here is 26.1 meters per second, or we can just leave it as 26. So these are the two velocities that we're looking for. So if we go back to our original question, we're going to see that velocity v1 prime, we have found 26.1 meters per second, while v2 prime, we have found 15 meters per second. So there we have it. This is how we break down this question. Thank you very much. Have a good day.